All right, welcome back to another technical session for QtCon Brasil 2020. Let's get started already in English because it's a bit weird to keep switching language, but mostly because our next speaker is coming from the lovely Barcelona, and we are here today with Aleix. Hi, Aleix.
Hello.
How are you doing today?
Great. It's finally getting cold again, which I was looking forward to.
Awesome. So Aleix is here as a KDE representative. The KDE community is a long-time partner for QtCon Brasil. They are with us since the first edition. And Aleix currently is with BlueSystems, which is an European company doing their business around Qt and KDE. But he's also the president of KDE EV, which is the legal organization behind the KDE community. For those of you who don't know, the KDE community is one of the largest free software communities and projects in the world, and also certainly one of the biggest showcase of how to use Qt for developing awesome applications. Aleix in particular is very kind, always come up with some very good talk for QtCon Brazil. At the first edition, he talked about Kirigami, and today he's gonna bring us the latest news from the Wayland land. And so that's it, Aleix. Please.
Cool. All right. Thank you. Can I get the screen thing? All right. Well, thank you very much, Sandro, for your kind words. All right. So generally, when I talk about, talk in a presentation, I generally talk about KDE products specifically. But for this occasion, I thought that it was worth taking a step back a little bit and talk about Wayland, which is a technology that we're based on, and see what it can offer us. Sandro, can you maybe mute your microphone because I can hear background noise, and I guess that the audience will hear it as well.
Actually, it's already muted. I will mute at the stream your session as well. Just a second.
All right. Well, I'm gonna go on. I know that Sandro already introduced me, but I am going to do it again anyways. My name is Aleix Paul. I am from Barcelona. I am the KDE president right now, and I've been developing KDE software and, basically Qt software for over the last 10 years, a bit more. I am employed by BlueSystems doing KDE software, and I am based in Barcelona. And right now, part of my involvement in BlueSystems is to improve our experience on Wayland. Now, before I delve into very technical bits, I would like to go a bit through the history of why is it so important right now, and why we've been talking about it so much, but so few of us have it running on our computers. And the reason starts because, like you will know, Linux, which is the solution for which Wayland was created, is based on Unix, and as a Unix system, it could use some technologies that were already available, namely X11, which had been around since much before that Linux actually started created, right? Actually, probably Linux was created on another X11 system, but then while it worked, and actually it took us from the 90s until the 2000s, at some point we realized that we wanted to be able to do some fancy stuff. X11 was designed to work on big mainframes. Actually, the big feature over there is the network transparency, so you can have a big computer that will have all of the sessions of your employees or students if you're a university or such stuff, and you will connect to it from Dabber clients, which is actually what people used to do it in the 80s. I wouldn't know because in the 80s I was a toddler at best. But that's kind of the idea. At some point, humanity realized that it was there were better things to do. OpenGL came into scene. Hardware accelerated graphics became a thing that had never been something done. So, well, when preparing this presentation, I figured I could show some video about how this used to work. I guess it's fine if you don't really see it very well, but you will get to see the kind of stuff that people who started to work on the hardware accelerated graphics were wondering about. This video I am showing is from 2006. You can find it easily on YouTube if you're interested, but you will see that basically they are showing how since a window, instead of being something that has been painted on top of a canvas, is just a texture, you start to be able to do all sorts of different things like transformations on the rendering of those windows, like making them wobble a little bit and stuff. If you were active back then, you will also remember the famous cube. Oh, you can see it now. Like, I remember seeing this video all over the place back then, and it was like, it was really cool, right? Like, none of us were used to seeing this kind of effects. Like, to us, or well, yeah, to the computer users back then, it was uh still a novelty to see like 3D stuff going on and such. Now, the avid listener is going to tell us, yeah, but this is something that you have been able to do in Linux without, or BSD and all of this, don't get me wrong, but without Wayland, right? Like, this can be done. But what kind of happened back then was that some very smart people who knew all about Linux and graphics and, well, Mesa and how everything works, decided to put together a plan into how we could make, well, this possible on X11, because that was what people were using and they wanted to be compatible with that. But in parallel, they also designed how it should be worked if we started developing it right now, which derived, as far as I understand, because I wasn't any of these smart people, by the way, it derived into what Wayland is today. Now, why am I explaining all of this? Well, I think that it's worth realizing that it's a huge change, especially for those of us who are not starting a product from scratch, but we are just trying to move our user base, our well, clients in a way, into the future somehow, right? And we need to have very good reasons, because in fact it's quite a lot of work. Like I said, part of my job nowadays is to get our working system on X11 into Wayland. Now we need to have good reasons why we would want that. And any of you who eventually might decide, let's ship a product to people, you need to be able to say, all right, this is my technology, this is what I'm gonna rely on. Now, well, these are the main reasons, I think, for choosing Wayland. Number one would be stability. And while I'm talking about this being a new thing, doesn't sound all that great, because in the end, it would be very useful and nice to rely on that thing written and debugged in the 80s. We also want to have well, a more simple kind of solution, right? When it's very important that our engineers, our people who work on the stack know how everything works. And in practice on X11, this was kind of mental, even impossible, I would say. Now, with Wayland, we're offering a solution that where the layers are much simpler, and they're more concentrated in into compositor. I'm gonna be talking about what the compositor is and everything is in a second. Um, it's also important because we want performance graphics, and I think that this would actually even be the number one reason for moving from X11. And in the end, if you want to get your application deployed, as soon as you say, I want to have graphics and, well, possibly I want to have more than one process, because in the end, like, you will know, you could spawn a process that just does your thing. That would be fine. But that would also only be useful if you're doing a very, very, very simple thing, like, I don't know, credit card machine or an ATM. I don't know. Like, it needs to be very ad hoc kind of things. As soon as you need separate components, you will want to have different things. And as soon as you do that, you will need to have in place the mechanisms that you need to be performant. And this is what the Wayland community has been working on over the last few years. And I am only a newcomer over here, by the way. But it's also very important. So things like, I need to make sure that I render quickly on my client, and getting that texture over there into the graphics card without having to moving it through memory and things like that. This is what Wayland is excelling at the moment. We also want separate components. We want to be able to have different applications that do different things. And if one of them crashes, for example, it doesn't bring all of the system down, which would be super sad and would make our product unreliable. This way we can do things like, if it crashes, we restart it, or we do whatever it needs doing, so that the user barely notices, instead of like losing data and anything like that. And something very important also for us who are coming from X11 is security. We need to make sure that we can have some clients, at least, that are not 100% trusted. And because otherwise the conclusion is that we keep giving all of the information to everyone, which in practice is what is happening on X11. And well, while it's been working quite well, seeing more and more people interested in providing third-party applications, and namely, closed source applications that you cannot properly verify and see that they do what they claim to be doing, is very important. Just so that you see what I'm talking about, on X11 we have a massive observer pattern where, every process gets to know about where the mouse is, what keys are pressed, and everything, right? And this is super powerful, right? Because, I mean, you get to know about everything, so you can react, you can make very smart experiences for your users. But on the other hand, you also end up in a position where, everybody knows what you're typing and why you're typing it to. So when you type a password, you type something, people would get to see it. And actually, this also ties with other developments around the community, like you will see with Snap and Flatpak, for example, which is mostly for distributing our applications, and also are trying to close down on these different problems. Now, going into the solution and how it works, which is, I guess, what people here will be interested about. How does it work? Namely, a Wayland system is composed by the compositor, which is the system that orchestrates how everything will work, and then the different clients. And by clients, I mean applications, but not necessarily on the traditional sense of application. Virtual keyboard, for example, would be a client as well. The lock screen would be a client as well. These kind of things. Now, between the compositor and the clients needs to be certain communication, and actually it's this communication that is happening between the compositor and the clients what Wayland is in fact. Wayland doesn't do anything about rendering. Wayland is the protocols, and well, there are a lot of protocols very specifically made for rendering. That's not it's not Wayland who is rendering. We generally use OpenGL for rendering. We could use other things like Vulkan, for example. In Queen, in our system in KDE, we do have a way to render that it doesn't use OpenGL. It uses QPainter as well, just in case you don't have OpenGL drivers in whatever system you're on. There's different kind of solutions that you can use, because the important part is to be able to get all of the information from the clients and then put it on the screen or put it anywhere, right? Really. Because in the end, it's not only about putting it in the screen, it's about as well being able to support things like VNC and well, all of these protocols that are super important and we give for granted, but somebody needs to implement them at some point. Regarding the protocols, I've been talking about graphics a lot, but we need to understand that it's kind of everything that the compositor needs to tell the clients and vice versa, right? So this will include other things like input, for example. It will be the compositor that tells this key has been pressed on a keyboard, or this emoji has been pressed on this virtual keyboard, these kind of things, right? Clipboard also is a protocol, etc. We can look into it a little bit further later if you're interested. I found this graphic that tries to explain a little bit what we were talking about earlier. You see that it has all of the applications. We could call them clients. The compositor does the compositing, and by compositing, it means actually rendering each screen where it should be. But then, and then it does the sending into the physical display, which, by the way, it's send it into the physical display just in case it's what you want to do, right? But like the compositor can choose to do whatever it thinks would be best. And it would include also the input protocols. And it's also interesting to understand, and actually this is something I struggled with, was that it's not the application that is listening to the keyboard, is the compositor that is listening to the keyboard, to the mouse, to the whatever, to the Wacom tablet, and it's a compositor that is telling all about it into the application. Now, I keep talking about graphics, but then when I was defining what Wayland is, I started to go all about protocols. So let's, first let's try to see what it looks like. So we can settle ourselves into, a shared communication framework. This is a dummy thing I did so that I was not like pasting you a huge XML file that you had to parse while listening to me. But what you can see here is basically a protocol. Protocol would be something you're doing, and inside you will have interfaces. You can have several of them. Here I have the potato interface. For example, if we were thinking about the tablet protocol, you will see the tablet protocol, and in interfaces you will see, first the manager, which will be listing your things, and then you will find the tablet itself, and then the pen interface, etc. Now, inside of the interface, you can see there's requests and events. You have to read these protocols as from the client perspective. So in this case, the client can call a get potato, and then it also can listen to the cooked events that they're happening. So basically, this tries to define the kind of things that you can tell to the compositor, and the kind of things that the compositor will be telling you back, and that you have to listen to in practice. Now these protocols need implementing. Here you can see, if you go the list of all of the standard protocols. Um, let's see if I can go and you can still see it. Okay, like you can see here, there's the stable and the unstable branch. The stable are those that everybody, if they want to say they are decent Wayland compositor should support. You know that this is not going to change over time. So as a client as well, you can implement it and know that this will, well, also stay over time, right? On stable, you can see, stable. You can see those three only. And actually, the really, really important one is the exe shell, which is the one that we use nowadays for well, for defining a window and setting a title on it and a bunch of things like that. Now, on the stable ones, we have those that we felt like we needed on the different experiences that we have for Wayland, but they are not really polished and closed enough so that they can go into stable. I think that the metric to be in stable is whether it has been implemented by two compositors and toolkits. For the for unstable, you only need to have one implementation of it. Well, here you can see the different unstable ones, which some of them are like fairly important and quite widespread anyways. Like, for example, I know that Gnome and Plasma, we do implement tablet. I think that Sway implements it as well. The MA buff is also quite widespread. The MA buff is one that is especially interesting, I feel, which is about having the client and the compositor use the same texture in memory, so they don't have to actually stream a texture every time. So you would render it in your graphics card, download in your client, use shared memory, and put it on the compositor. You can just tell the compositor, I have my texture over here, just use this one, and the compositor just uses that one without having to move it. I think that it's really cool, and it's part of what it makes the whole experience so much more performant than, well, other possible alternatives. And it also shows that people who have been thinking about Wayland do understand graphics and do know what is really important is. Other important ones would be maybe the text input one, which is for virtual keyboards. And well, yeah. If you want to see a really complex one, just to get an idea of what the real protocols look like, you can see how, well, they're all very well documented, which is something really nice and something that well, Upstream Wayland makes a good emphasis on. So if you want to see how it works, you get to read that and well understand it, which is to be appreciated. But you can see like it's a few hundred lines of code and documentation. In practice, the compositor, the protocol XML file is about documentation anyway, right? Like it's the description of how the protocol is going to work plus why it's working like this in a way. Back, there you go. Okay, now those were the standard protocols, but there's like several others because there's things needed that, well, often the compositors themselves will need to communicate with some of the more specific applications that one have, right? With the standard protocols, we don't really have all of the tools necessary right now to create a whole desktop for a user to be happy with. So the different implementations have been putting together some extra protocols to well, to fill that those gaps. Now the idea would be that eventually, if Well, or what we do is if we see that somebody else has already implemented something we need, we don't try to implement yet another one. We try to use the others and polish it. So when it gets stable, well, first we will already have the stable version implemented, which is nice. But also, well, we are building on top of the same knowledge rather than creating parallel one. I think that it's pretty important. Here you have, or you can see the URLs for ours, gnomes, and WR roots, but there definitely are others. I haven't really checked, but I know that Enlightenment has some stuff going on, and I'm sure that there's some more more niche to implement it. Now you have an XML file that that needs implementation. How do we turn that into our application? What we're using right now is something called Wayland scanner. It's an executable that you give the XML file and it outputs some classes that you can just directly use, and well, they will implement your protocol. My title of the talk was deploying with Wayland. My idea was that if you're creating a product and you want to offer a graphics alternatives, you can just put a compositor and you can put your applications in it and ship it as is. And there's several alternatives for that. One of the compositors that are already done is Weston. So you would get to only create your client or clients and use that Weston compositor for doing whatever you need. Weston specifically, for example, is Wayland only, and it's been developed by Upstream. So whenever a new feature is added to Wayland, a new protocol, they implement it and they make sure that it works. There's also some people already using Weston for delivering their products. So there's certain companies that have been developing it as well. There's also your Roots, which is a framework to create your own compositor, so you don't have to start from scratch. They are also using it to develop the Sway WM window manager, which is styling. It looks very hackerishy, but it's also Wayland only, and if you're into that, I guess that it's useful. There's ours, which is Quinn, which is the one that powers Plasma and the different Plasma products. We've made it a scale from desktops to the Plasma mobile phones. It's fairly light, and we're adding features every day to make sure that all of the extensions that we might need are implemented. There's also Kit Wayland Compositor. I here added a video that describes how it works exactly. It was done by Yona, who used to be the Kit Wayland maintainer. And I think that if you're using Qt already, it could be useful, a useful way to get acquainted with that product. And there's others as well. For example, Gnome, they have their own as well. Big slight difference there is that they have the shell itself together with Matter, which is their compositor. So I guess that it would be a bit weirder to base a product on it, but I guess it should be possible nevertheless. Now, if you're used to using Qt for your applications, there are some certain caveats that you need to be aware of. Like Qt works perfectly well on Wayland, but there are certain things that will work different. Specifically, those things that are specific to the platform. For example, the compositor is the one who positions the application. You cannot tell the compositor I want to be at XY, 23, 34. You have to give yourself a size and go with it, or implement a protocol to tell the compositor where to place your application. Right, this is something that it's important, but it's also important for very few applications, and actually the kind of applications that you don't want to that you want to make ad hoc for one experience, but not normal applications. Right, an example would be as well like notification and stuff. The reason why this is like this is because you want to make sure that you cannot have applications that sneak into weird positions and, well, try to steal your data this way. Another big difference, specifically with X11 and I believe Windows as well, is that you don't get to observe other processes events. You have to, you will only get, for example, the QE presses for your application when it's focused. When it's not focused, the normal thing is the compositor not to send them to you. So if you want to do things like global shortcuts, for example, you will have to, well, tell the compositor, I want this shortcut, tell me when this happens, right? But you won't have every process listening to all of the key presses, hoping that it's theirs, and then hijacking it, potentially having two processes listening to the same stuff. And also, well, you have the big advantage that you won't have other processes listening to your password key processes, which is always very welcome. I think that this is it. I think that it could be useful if you have some questions. Otherwise, we can expand on any part of the talk.
Great, thank you, Aleix, for this nice talk. I think we are all believe that Wayland is the way to go if you want to reach the next level for those modern applications. And so now we can move to the Q&A session, part of this session. And so I see one question on our YouTube chat from André Agenor. He's asking, is the compositor responsible to optimize the render to screen? Do they use BVH, quad trees, or any way to do not render everything all the time?
Yes. Well, can you maybe write what BVH is, because I am not sure. I can answer the rest of the question anyway. The compositor is definitely in charge of keeping track, for example, of all of the damaged areas. Like part of the surface protocol is to tell the compositor these parts of my application change right now. So as a compositor, you can know that, for example, if all of these damaged regions are occluded by another window, you can decide not to send it to the display, because you would be doing the whole loop of going through all of the windows, rendering them, putting them on the display for no reason, right? So all of these parts, they're definitely responsibility for the compositor. It's responsibility of the client to do the rest, which would be making sure that the damaged regions that you send are the true ones. You, as a client, you should also be telling what your opaque regions are, because this way the compositor can do more optimizations on your code. We do need to have some certain scene graph on each compositor to decide where all of these go. And actually, in Queen, we're in the discussion right now on whether to create a better one or look for a third-party one that could be useful to us. But there's definitely more things that could be done. Something interesting as well that we get to do on Wayland is the use of subsurfaces, which basically are a separate surface. So if you know that you will have two parts of your application that are rendering different things, and maybe you need one to do something slightly different, you can put the other part in a subsurface, and the compositor is responsible for putting one surface onto the other, depending on how you explain that your surfaces should be placed, and you will get to do that. An example of an application that does that, for example, is Firefox, that right now I think it's the tabs that are in a different subsurface than the application. There might be others. There surely are others.
Great. We have another question from our friend Nuno. He's asking, when will you have enough feature parity with X11 so that we can all move to Wayland?
As I see it, the features are getting there. Especially in Plasma 520, you will see that there's a lot more implemented. I have been using Wayland and Plasma on my laptop over the last 2 years, and while I admit that when I started using it, it was a bit painful, it's gotten less and less. At the moment, I would say that you could use a Wayland session without really noticing, especially on 520. The last thing that I think was pretty important was the clipboard support, which, well, is there right now. But it's this kind of things, right? Like the clipper wasn't supported. Actually, it wasn't not even the clipboard. The clipboard was working clipper, so the history of your clipboard wasn't implemented. It is right now. Um, yeah. Also, there's other features that you will be getting as soon as you adopt Wayland that you didn't have on X11. That said, from Plasma, we've been adamant to say right now X11 is not supported because we know that a lot of our users are using it, and well, it's not very nice to tell people that they should be using something different. We do know though that X11 development is quite stale right now, and for example, there's distros that are planning to deprecate it, such as Fedora. And actually, Fedora is considering making us default on their KDE spin. Us, I meant Wayland making it default for their KDE spin on the next version or two. So it will also be a decision of the different distros to decide how this ends up on the users. As KDE, we could maybe do it for Neon. That's a possibility. But I would recommend anyone to give it a try if you're already using Linux and even Plasma. Give it a try, and if there's something that you really, really, really don't like and that can make your experience that worse, then you tell us and we can look into that. But it actually should be working already. And for example, it should work faster for you and well, lighter.
Cool. And so I see no further questions in our YouTube. Maybe I have one from myself. And so looking at the global picture and with a focus on KDE technology stack, it's still not totally clear to me what parts of Wayland is currently addressed by Qt and by Queen, so that for application developers, we shouldn't be concerned of any issues regarding Wayland, right?
Well, the idea is that if you developed your application on Qt, it should just work. Meaning, if you develop your application on Qt, it should just work on Windows as well. It should work on OS X as well, right? Or Mac OS. It should also work on X11, and it should also work on X11. Well, yeah, all of them. Everything should work with Qt, right? Now, there are certain protocols that Qt might not be implementing. At the moment, in from Plasma, we're using only the Qt Wayland client parts. So we only use Qt Wayland for clients. For Queen, we're implementing everything from scratch except for the Qt Wayland scanner, like that I mentioned earlier. This one we do use, but other than that, we are relying on our own code for whole rendering and the server interfaces. We're not using Qt Wayland compositor. For clients, on the other hand, we're just using Qt Wayland client. And well, there's some protocols, for example, the Plasma specific ones that we do implement ourselves in our software. And then for that, there's a Kwayland framework that you can use, that you just use it as a normal library, and you have classes that are already prepared for you to integrate on your application. I did explain how everything worked on my talk at Academy. Maybe you can put the URL somewhere at some point, and if people want to, or if you want to know more about how we implement Wayland on Plasma, you can take a look there.
All right. So there is another question from André Agenor. Is it ready to use with NVIDIA cards?
Well, there is. We do have. So the thing, the reason why Andre is asking is because at some point, NVIDIA decided that they didn't want to implement the MA buff, which actually we mentioned before already. They wanted to implement something they called EGL streams, which is, as far as I understand, kind of the same thing, but well, the one they implement, right, is for passing the textures from your graphics card into your, well, from one process to another, right? So you need to make sure that, well, the system you rely on is implemented. Initially, it wasn't implemented on our end, and actually, the initial patch that did the port was done by someone in NVIDIA, if I am not mistaken. I might be. But in the end, the idea would be that, yes, it's supported. That doesn't mean that it works as well as others, because it's definitely less tested. I know that David, for example, who's one of the maintainers in Plasma, he does have a system with NVIDIA, and he tests it every now and then. But so yes, it should work. If it doesn't, report a bug. Thank you very much. We'll do right now. Obrigado.
Bye bye.